significance of cross product? Can you tell me that? The physical significance of cross product was, if we have this particular vector, right? And if we have this vector, so A vector is there and B vector is there. So basically, A cross B shall give me what, Atul? A cross B shall give me the what? A third vector C. And that third vector C would be perpendicular to both A cross B.
Both A and B.
A and B, correct. So basically, C vector is perpendicular to A vector as well. And the C vector is perpendicular to A vector as well. That's what basically A cross B basically means. You understand? Right?
Yes, ma'am.
So this is what we calculated. So using the A cross B method, I told you that how actually the area of the parallelogram came. So this was my parallelogram. So this was side A vector, and this was B vector. And they were adjacent sides. So here, what do you think you will get? You will get A cross B, and then the modulus of that A cross B shall give you the area of the parallelogram. Yes or no?
Yes, ma'am.
Right? Now, similarly, if for example you are given a triangle, if for example you are given a triangle, and here this side is A vector and this side is B vector. So here the area of triangle is nothing but half of A cross B. Very simple now. So all you have to do is the A cross B. Okay? All you have to do is the A cross B and then find its magnitude and calculate the half of it. Are you understanding my point? So
Yes,
this is
ma'am.
one component, one method. Then the third formula that you need to remember is, here you have to keep into mind that in this first type, where you are supposed to find out the area of the parallelogram, A and B are the adjacent sides. Okay? A and B are the adjacent sides. What exactly does that mean, Atul? A and B are the adjacent sides. That means that we have A vector and the B vector. They have one common vertex. That's what you call something as an adjacent side. Okay? So when two sides have a common vertex, so two sides having a common vertex is called as a adjacent sides. But sometimes in the question, it is also given that you have to find out the area of the parallelogram, where the red diagonal is your A vector and the blue diagonal is your B vector. Are you understanding? So then
Yes,
the
ma'am.
area of parallelogram shall be, then the area of parallelogram equals to half of A cross B. Half of A cross B. Okay? Then the area of the parallelogram shall be same as the area of the triangle. But provided that A and B are the diagonals of the parallelogram. So depending upon the question, what the question is saying, that is it a diagonal of the parallelogram or is it a adjacent side of the parallelogram? Depending upon that, you will identify the question and then you will apply the formula. Okay?
Yes, ma'am.
So it says A and B are the diagonals of the parallelogram. So that is how you are supposed to find the area of the parallelogram. So two methods to find the area of the parallelogram. One is half A cross B, and another method would be what? Another method would be A cross B.
A
But
cross
in
B.
that A cross B, A and B were the sides, adjacent sides. And in the area of the triangle, second part, again A and B were the adjacent sides. You understand? But
Yes, ma'am.
here in the parallelogram, second method, A and B were the diagonals. A and B were the diagonals. Yes or no?
Yes, ma'am.
So that is the concept. Now understand. The next type of question that you will get is one type. So they will give you 2 points. They will give you 2 points in the Cartesian plane. In the Cartesian plane. And you understand how basically does that work. For example, you see I have this y-axis and this as my x-axis. Yes or no? And let me mark the point. This is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. And this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Now let us suppose I am at point 1 comma 2 comma 1. And then I have another point which is, let's suppose, 6 comma 5. Alright. And I
Yes,
want to
ma'am.
know the starting point of somebody is A and some person is moving from A to B. I want to know what this vector A B shall be called. So now you tell me, how exactly do you understand from this point? Just tell me this point. Like, for example, if I say this point A is effectively I have moved 2 I cap, and to reach A point, basically I have moved along Y axis as 1 J cap. Yes or no?
Yes, ma'am.
So effectively, this point is 2 I cap plus 1 j cap, because we know that now on the Cartesian plane, how do we sort of mark the points? We are moving to reach the point A. I have to move 2 I cap forward and 1 j cap upward. Yes or no? So
Yes,
that
ma'am.
basically means if we are completing the triangle right here like this, so I will be reaching at point A. So the point A shall become for me 2 I cap plus 1 j cap. Now, basically, to reach from point A to point B, you tell me how many steps forward you need to move. 1 I cap, 2 I cap, 3 I cap, 4 I cap. Yes or no? And
Yes, ma'am.
basically, here on along the y axis, you have to move how many I caps? 1 J cap, 2 J cap, 3 J cap, 4 J cap, 5 J cap. Yes or no? But if
Yes,
you
ma'am.
look at the starting point from A, 1, if you look at the starting point of A here, so we have to effectively move only 4 J cap. So on that note, if you look at this particular line, according to triangle law, you will say that, ma'am, this is 4 I cap and this is my 4 J cap. So by the triangle law, what do you think you can say? That this is in sense, the two big vectors are in sense. So according to the triangle law, don't you think it should be 4 I cap plus 4 J cap?
Yes, ma'am.
Right? So what I'm trying to tell you is that when you are given two specific points, 2 comma 1 was the starting point A and 6 comma 5 was the ending point B. Okay? What am I trying to tell you here is, I'm trying to tell you that you have to do what? You have to do what? We have B, right? So what am I going to do? 6 minus 2. So this is x1, y1, and this is x2, y2. So I will make the vector. So I want you to tell me what is vector AB. So AB vector shall be x2 minus x1 I cap plus y2 minus y1 j cap. So 6 minus 2 I cap plus 5 minus 1 j cap. That shall be vector AB. Yes or no? But
Yes, ma'am.
AB vector shall be 4 I cap plus 4 j cap. Understood? So what you're supposed to do, subtract the first x1 from the second x1, x2, I cap, and y2 minus y1. So this is my y2, this is my y1. So y2 minus y1 j cap. Understood or no?
Yes, ma'am.
Any doubts in this? So whenever you're given 2 points, like suppose if I am given a point A and that point is x1, y1, z1, obviously it can be there. And there is another point B in the Cartesian plane x2, y2, z2. So my AB vector shall be what? My AB vector shall be x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Alright? So this is how you make the vector when 2 points are given to you. Understood or not?
Yes, ma'am.
Alright? Now, next point that we have to understand here is this. What is this? So there are two terms. One is called direction ratio. Okay? And another one is called direction cosine. Now, why it is called direction ratio or direction cosine? Because it is telling me in which direction am I supposed to move, isn't it? When I say 2 I cap plus 3 j cap plus 5 k cap, so that clearly is indicating me that when you are moving along origin, when you're moving from origin along x or y or z, what exactly are you going to do? Tell me. You're going to move 2 steps forward, you're going to move 3 steps upward. So this 2 is telling me that move along x. 3 is telling me move 3 steps along y. 5 is telling me wherever you have reached now, move 5 steps upward towards z. So that is why the numbers which tell me the exact direction, you know, that is called as the direction ratio. So how do we write down the direction ratio? The direction ratios are written like 2, comma 3, comma 5. Understood or not?
Yes, ma'am.
Basically, the coefficients of I, J, and K are called as the direction ratios because they are telling me in which direction am I supposed to move exactly, to make the main vector. So that is direction ratio. Are you understanding?
Yes,
Now,
ma'am.
similarly, when we are talking about direction cosine, what exactly do you think it would make? Tell me. When we are talking about direction cosine, what exactly do you think it is going to make? Direction cosine basically means what? That if I have the same vector, right? What you do, direction cosines are the coefficients of are the coefficients of I cap, j cap, and k cap in the unit vector. In the unit vector. You understand? So, for example, if you have the same vector 2 I cap plus 3j cap plus 5k cap, 2 I cap plus 3j cap plus 4k cap. So, you will say the direction ratios are 2, comma
2, 3,
3,
and
comma 4. Sorry, 2, comma 3, comma 5. But now I want you to tell me the direction cosines. So, how do we calculate direction cosines? What are we going to do? We are going to have the vector. So, let's name this vector A. So, this vector A, if we have 2 I cap plus 3j cap plus 5k cap. So, what is the A magnitude? What is the length of this particular vector? 2 square plus 3 square plus 5 square under root. That's what we have learned up till now. So, that shall be 4 plus 9 plus 25. Are you understanding?
yes, ma'am.
So how much is that going to be? That is going to be 13 and 25. So that is going to be 8 and 38. So that is going to be root 38 centimeters. So this is the root 38. So root 36, if it would have been, it would have been 6 centimeters. So it is something little greater than 6 point something centimeters. So I would say if the length is 38 centimeters, root 38 centimeters, the vector is written down as 2 I cap plus 3j cap plus 5k cap, isn't it? So if the
Yes,
length
ma'am.
is 1 centimeters, it is written down as 2 I cap plus 3j cap plus 5k cap over root 38. And this is the vector. So basically, if I draw on the Cartesian plane, if I say that, x and y, if this is some vector A, so that original vector, if it is a full length root 38, it shall be written down as 2 I cap plus 3j cap plus 5k cap. But the vector along this same vector, but of length 1 centimeters, it shall be written down as 2 over root 38 I cap plus 3 over root 38 j cap plus 5 over root 38 k cap. You understand my point?
Yes, ma'am.
So, along the same direction, but another vector of length 1 centimeter. That is a unit vector that we have calculated already. So here, if I write down the a cap here, the a cap vector, it shall be 2 over root 38 I cap plus 3 over root 38 j cap plus 5 over root 38 k cap. So these coefficients of I cap, j cap, and k cap in the unit vector are called as the direction cosines. So now if somebody asks you, what is the direction cosine for this particular vector? So indirectly, they are asking you to calculate the unit vector first. Then you calculate the unit vector, and then the coefficients of I, j, k cap it will be called as what? So that shall be direction cosines. So for this particular vector, the direction cosine shall be 2 over root 38 comma 3 over root 38 and comma 5 over root 38. Are you understanding my point?
Yes, ma'am.
All right. Also, you understand why exactly do we call this? Understand. So, for example, we have this y axis, this is my x axis, and this is my z axis. Now, just see. For example, if we have this particular vector. So, do you understand that this vector's length is root 38? And this vector is actually making an angle theta or alpha, you know, with the x axis. So when this vector, whatever is my vector, a vector, is making an angle alpha with the x axis, can you tell me what is the value of cos alpha? Cos alpha, so this is my distance x. So x over root 38, isn't it? Because
Yes,
obviously,
ma'am.
x is going to be the base. For this particular triangle, this is my perpendicular, this is my base, and this is my hypotenuse, the length root 38. Because the amplitude, the magnitude is nothing but root 38. I hope you're understanding
Yes, ma'am.
what I'm trying to tell you. And how much is x that we have traveled? You tell me. To actually make the vector a, I have traveled 2 centimeters along x axis. So this x should be nothing but 2. So I'm going to write down 2 over root 38 is going to make base upon hypotenuse, isn't it? So don't you
Yes,
think
ma'am.
this is cos alpha? Don't you think this is cos alpha? So what is cos alpha? And you can see that very clearly that 2 over root 38 is this the direction cosine. Do you understand why do we call it direction cosines now? Because that is equal to the cos theta value from the triangle if we make. Because we are trying to find out what angle is this vector making with the x-axis. You understand?
Yes, ma'am.
So this vector is making some angle definitely, you know. And what is that angle we are trying to find out? We are trying to find out alpha. Yes or no?
Yes, ma'am.
Understood or not?
Understood, ma'am.
So similarly, if you're trying to find out the angle that this vector, blue vector, which is the A vector, is making with the y-axis. So can you understand from this line that this should be my beta angle? Now, if I have to calculate the beta angle, just understand how much this should be. This should be 3 centimeters. Because to reach this particular B point of my end of the vector, what do you think we have to do? Tell me. We have to travel 3
Three.
centimeters along J y-axis. So if I take this, so if this is my beta, don't you think this should be my perpendicular? So this should be base. And this is root 38. So don't you think again if I calculate cos beta, that should come out to be what? Base upon hypotenuse regarding beta. So we right in front of beta is perpendicular. So this is going to be 3 over root 38, isn't it?
Yes, ma'am.
So that is why I can clearly conclude that if my vector, if my vector, this is my x-axis and this is my y-axis and this is my z-axis. And let's suppose this is my vector. So if this vector is making an angle alpha with the x-axis, beta angle with the y-axis, and gamma angle with the z-axis, this is my vector A. So how do you think I'll be able to calculate this angle? So I will say cos alpha is nothing. So if A cap, A I cap plus B j cap plus C k cap is my vector R. So what shall be the R vector's magnitude? A square plus B square plus C square under root. So R cap shall be, that A I cap plus B j cap plus C k cap over under root of A square plus B square plus C square. I hope you're understanding my point. So this is my unit
Yes,
vector
ma'am.
that we have calculated. And now if you want to calculate the cos alpha, what would that be, Atul? It would be cos alpha shall be what? It shall be A over under root of A square plus B square plus C square. I hope you're understanding because this much distance we have traveled is A, because we have
Yes,
traveled
ma'am.
this much. And this is A square plus B square plus C square under root. Yes or no? And this much distance
Yes,
is
ma'am.
A, this much distance is B. So when we are trying to find out angle alpha, I would say I would consider this particular angle. When I'm trying to find out angle beta, I'm going to consider which angle? I'm going to consider this particular angle. You understand? And
Yes, ma'am.
then when you look in 3D, so in a different quadrant, definitely we'll be considering a triangle with angle alpha, with gamma. So in that sense, what we are going to write down? We are going to write down cos alpha is this. Cos beta shall be b over under root of a square plus b square plus c square. And cos gamma shall be c over under root of a square plus b square plus c square. Do you understand my point?
Yes, ma'am.
Understood. So now if you
Understood.
see this, these are my direction cosines. So direction cosines, now it should be very clear why we are calling them direction cosines, because these are nothing. The coefficients are nothing. The coefficients of the unit vector are basically giving me the values of cos alpha. That is, alpha is angle that the vector makes with x-axis, cos beta, and cos gamma. So I have the value of cos alpha, I have the value of cos beta, and I have the value of cos gamma. You understand?
Yes, ma'am.
And on the similar lines, if you see, if I have this 2 over root 38 I cap, 2 over 3 over root 38 j cap, plus 5 over root 38 k cap. This is my a cap. And if I calculate the length of this a cap, do you understand 2 over root 38? So I know this part. 2 over root 38 is going to be cos alpha. 3 over root 38 is going to be cos beta. And 5 over root 38 is going to be cos gamma. So if I square and if I add them, and these terms are also mentioned like this, they're also denoted by the symbol L, M, and N. So it is going to be 2 over root 38 plus 3 over root 38 whole square plus 5 over root 38 whole square. Are you understanding? And just add them
Yes,
up, it
ma'am.
is going to become 4 over 38 plus 9 over 38 plus 25 over 38. So what am I doing? Basically, I'm trying to find out L square plus M square plus N square. So if you add this up, the denominator is the same and the numerator also adds up to 38, because 4 plus 9, 13, 13 plus 25, 38. And that comes out to be 1. So can I conclude from here that L square plus M square plus N square is nothing but 1? And cos square alpha plus cos square beta plus cos square gamma shall also be 1. Understood or not?
Yes, ma'am.
So this is about my direction ratio and direction cosine. You understand?
Yes, ma'am.
right? So this is the concept. So you have to understand one very important thing, that when we are for a particular given vector, if somebody asks me the direction ratios, this is my vector. So you simply calculate direction ratios is just the coefficients of I, j, k. But if somebody asks you direction cosine, they're actually asking you what is the value of the cos theta of that particular angle that the vector is making with x axis. So what do? You take the vector, you calculate its unit vector, and then the coefficients of I, j, and k become my direction cosines. Do you understand my point?
Yes, ma'am.
On the similar lines, if you have this particular part, so you have calculated this. So okay. So then this, then I told you how it exactly came out to be cos alpha. Why only cos alpha we are calculating? Because the values that we're doing with respect to A, the angle that is being formed is alpha. And thereby this is A. And this is my hypotenuse. So base upon hypotenuse forms cos alpha. And this is the property. So these properties, you will have these kind of questions in your textbook or in your worksheet that is being given to you. All right. Is this concept of direction ratio and direction cosine clear to you, Atul?
Yes, ma'am. Clear, ma'am.
Right? So two properties, very, very simple ones. And that's it.